Thank you so much. Thank you also for inviting me to give this talk. So the original title of this talk was something different, but they told me that it is too long and it will look a little bit weird on the poster, so they asked me to shorten it. But the original title was this: Cybersecurity Dimensions of Artificial Intelligence, Blockchain and Cryptocurrency Technologies, NFTs, Internet of Things and Post-Quantum Cryptography, and how to preserve your privacy and security when your phone listens to everything you write and say, and when we can break every GPRS, GSM, RFID, and telecommunications, or how I stopped worrying and started loving cryptography. So I request 1 extra minute for the talk since the title was this long. So this will be the outline of the talk. I hope I can talk about all of them. But it also looks like I Googled what are the buzzwords in 2025, and these are the results. But really, I will really talk about all of them. But if you want to publish a paper, just took some 2 buzzwords from this list. For instance, say that blockchain solution to, for instance, healthcare security using artificial intelligence. It doesn't matter what you say in the abstract, it gets accepted as a paper or project. But most of them are wrong. Anyway, so I will try to cover all of this. So, of course, I will be focusing on privacy and security aspect of these topics, but I will also try to focus on misconceptions, because all of the misconceptions also leads to security problems, because when you don't understand something, you cannot provide security in that topic, okay? So let me start with the artificial intelligence and how our privacy is lost and what we can do about it. You know, sharing a picture of you with your friends might contain location, tag people, biometric data like facial features, habits, etc. Of course, you may choose not to share them. But the misconceptions are, if I don't share personal information, nobody can get any crucial information about me. This is not correct, because even if we don't know anything about you, you are the average of your friends. So AI thinks that whatever your friends are, you are also in that opinion or in that set, let's say. Another thing is, my data is only used for showing me targeted advertisements. This is not also correct, because actually we can do micro-targeting so that your weaknesses can be used against you. So this kind of knowledge can be used to alter your choices or ideas. Okay, so let me give some brief definitions. When you use artificial intelligence, machine learning, or deep learning algorithms on big data, you can do the following. AI and machine learning techniques can be used on big data to obtain patterns that are impossible to or improbable to detect by human inspection, and they can be used to categorize data owners and score data owners. So I will try to explain what this scoring will be about. Okay, but let me give a basic example. So assume that 2 different users are only sharing food pictures on Instagram. So you might, as a human, you perceive them both users as similar, but an Instagram user might be labeled as happy for posting food pictures. However, you might be labeled as jealous for posting food pictures. And this might be true, maybe you post those pictures just after you see other people sharing happy moments. Okay? So such a pattern is very hard to be detected by humans, but AI ML algorithms can easily detect such patterns. So let me give you how much data you leak, because people think that only data I leak is the stuff I share on Instagram, Facebook, etc. But actually, all of your movements on the internet are recorded and sold. Okay? So let me give you a brief example. So last September at Informatics Institute, we had to do an executive board meeting, and we had to choose a date for it. So we shared the Doodle link. So I followed Doodle, then this stuff appeared. Probably you are all familiar with it, and this is actually a good one because others goes until this, so you just don't read it and press accept all button. But this was surprising. By the way, accept all button is weird. What does all mean, right? What am I accepting here? And the second thing that I was super surprised not to see a reject all button, because If you want to reject this stuff, so you have to press the show purposes button, then select a lot of stuff and choose only the necessary stuff. So generally people get tired of this and simply press accept all button. But the thing is that at the time of this event, I was in Los Angeles, and California is the kind of have the best privacy laws. So actually in California, you cannot do this. There should be a reject all button with the same color, with the same font size, etc. California laws enforce this. Then I realized that my Meta VPN is open. For those who doesn't know what a VPN is, so actually my computer, although I'm physically in Los Angeles, my computer connects to a device here in campus and then connects to Doodle. So Doodle thinks that I'm a Turkish person. So I turned off the VPN and refreshed the page. Now this is what you see. Accept cookies, reject all, same colors, same font, and another button, do not sell my personal information. So as a Turkish citizen, you cannot choose this kind of buttons. So all your data is collected and sold. But if you live in California, then you can opt out for this. So, all humans are equal, but some of them are more equal, right? So you might also say that, okay, I only post stuff, but only they are visible by my friends, so that not other people see that. So at this point, maybe you trust Google, Facebook, that kind of companies, but the thing is that your data leaked many times. And these bubbles, the bigger the size, the bigger the amount of data lost. For instance, Indonesian SIM card lost 1.3 billion user data. And there is Turkish citizenship database around here, which is kind of small compared to all of this stuff. So I really like this webpage, shows you the recent big leak. So your data leaked many times, and by the way, the yellow ones has a interesting story behind it. So I recommend you to check it, because an interesting story is something like this. For instance, the admin password is admin. So this is why 500 million people's data is lost. So I think we agreed on everything about this. So your data leaked a lot of times, but actually you leak more data than you think. So let me show you some advertisements Meta don't want to show you. So technology is not built for you. It is built for your data. Data is the new oil, so it is super expensive. And as you know, almost all of the applications we use are free, like all of the social media applications or the messaging apps like WhatsApp are free. So this is because they collect your data and sell your data. So this is how they profit. So Meta collects everything about you from Facebook, Instagram, and WhatsApp to sell visibility into people and their lives. Advertisers buy access to your personal data, so you can easily pay money and get this data. Of course, one idea is that they are anonymized. So Google knows everything I do on the internet, collects everything. But instead of recording it as Cihangir Tezcan, it records as a huge number. So it kind of anonymizes that data. But if I go to Instagram and log in, Instagram knows that I am that huge number. So it is easy to assign who this number belongs to. So anonymization actually doesn't work in real life. Anyway, in May 2021, people at Signal bought some Instagram ads. And what they did was, as advertisements, they showed the user's personal data back to them. So think about it. In the past, you didn't know any data about you. So whenever you show an advertisement, you don't know, for instance, if you're selling clothes, you don't know if the person who is visiting is woman or man. So with an if statement, you can say, if it is man, show this advertisement. If it is a woman, then do this. So you can write any kind of programming code with that data. What Signal does was the following. They obtain this data and show back to the users, saying that we know this stuff about you. And this transparency got them banned. So these are some kind of advertisements people see. For instance, one user, when surfing on the Instagram, showed this advertisement. You got this ad because you are a newlywed Pilates instructor and you are cartoon crazy. This ad used your location to see you are in La Jolla. You are into parenting blogs and thinking about LGBTQ adoption. So this much data, you can simply pay a few $100 and get about that user. So when you show this to people, and this account was disabled, so Meta doesn't want you to tell how much data you know about people. So you can now understand that how much data leaks, okay? Good. So even if you try to hide it, it's very easy to gather info about your race, gender, age, sexual orientation, political view, religion, ethnicity. Again, even if you don't share it, your friends share it, so you're the average of all of your friends. Your action and behavior can also leak this info about your contacts. These and many other info can allow artificial intelligence algorithms to perform profiling. You can be categorized as happy, depressed, suicidal, newlywed, drug addict, Muslim, homosexual. So machine learning algorithms are very good at categorizing stuff. But there will be always false positives. That is the problem. None of the AI algorithms work with 100%. So they will make errors from time to time. Even if it is 99.9% correct, sometimes it will make an error. So from this profiling, you will have an AI ML score, like a credit score. Sometimes they are used for innocent purposes, like, to show you, for instance, people you may know on Instagram. These scores might be used for that, but these can also be used for different things, like when you apply for a job or apply for a visa. So let me mention an example here. Big companies receive thousands of applications for their job openings. It is not possible to invite all of them for an interview. To reduce the number, they can get a service from an information broker company. They will order the applications depending on their AI ML scores. So you won't receive a human inspection. All of the PDFs will be sent to an AI algorithm, and you will get a score. Problem is, maybe in your CV you use the word that not everybody uses, or maybe you made a typo, so your score may be slower than you might think, and just for this reason, maybe you're not selected for the interview, okay? Similar thing can happen when you apply for a visa. So if you have a very similar name with somebody else, and if their score is low, maybe the AI company confuses you with that person, so this might be the reason your job application got rejected, and there are many recorded examples for this, or maybe your visa got denied. So let me show you a basic example of how this can happen, and then we can understand what can go wrong, okay? Some AI ML algorithms act racist and sexist, and let me explain with an example why this is the case. Actually, we all realize this is happening with this kind of an incident. So many minorities' credit application got rejected with a statement indicating that there was nothing wrong with their application. So generally, in the past, when your credits rejected or your visa rejected, you didn't get any explanation for that. But in some countries, they passed some laws, so now the bank has to give you an explanation. But the explanation was that there was nothing wrong with your application, but we rejected your application because people like you failed to pay their dues in the past. So here, when you say people like you, and you systematically reject all of the black people's credit applications, then you have to wonder why AI is doing this, right? And the thing is that, so if two people with the same credit score apply for a credit, the results might depend on if they are white or black. This is what we observed. But it is illegal to ask race in credit applications. So how the AI knows if the person is black or not? Okay. So we realized that when you apply for this application, you have to give your address, right? And black people live together. So this way, from the address, the algorithm notices who is black, Hispanic, or white. But again, the problem is, even if the algorithm understands that the person is black, why the algorithm rejects them to have a credit? The thing was that the wealth is not equally distributed among black and white people in the United States, right? So your training data for AI is the historical data, and that data is not equally distributed between these races. So it is biased. So how you can solve this problem? You can, so by the way, all of those black people, if they move to next street, their credit application got accepted. So one option is to remove this address to be used as the AI training, but then banks has to give a lot of credit and they lose money. So, but this is how it works anyway. So something we call this crypto wars, and it is back. And many governments want to listen to everything you do. Okay. So this happened in European Union. They say that we want to stop child sexual abuse, which is good. We want them to be stopped too. But they said that for this, we will listen all of your communication, WhatsApp messaging, images you send, videos, but with an AI, okay? And if we detect something wrong, we will act on it. But the thing is that if there's no doubt about me, why are you listening all of my communication, right? So we realized that we cannot stop this, and they are not consulting to academicians or lawyers, they are consulting to AI people. So we wrote an open letter. It was signed by many experts in this area. For some reason, I was the only person that signed from Turkey. And I was, so the media contacted me. I even gave some report to news. But as you can see from the title, nobody read it. But we kind of won, by the way. With this open letter, we prevented this law to be passed. And then they admitted that with that law, they were actually requesting unlimited data access. So think about this, all of your messages, videos, everything you do is scanned by AI algorithms and it is reported back to Europol. So we kind of stopped this, but it is coming back again and again and again. At some point, we may not prevent this happening, and we may lose all of the privacy and security we have. And this kind of thing actually happened in United Kingdom recently, maybe you know. UK said Apple that we want to, whenever we need, we want to look at the data of Apple users, so don't encrypt the data on the cloud. So if you're a UK citizen, your data on the cloud is not encrypted, so police can look at everything you do and that you record on the cloud. So Apple is trying to fight back. They are going to court, but it will take years for this to be solved. But currently, UK people have no security when they use Apple products there. So when they take a photo, storing it on the cloud may not be good for them. Okay, so when we prevented this, a very strange thing happened. So we were kind of, people were angry to us. And we started to see this kind of stuff saying that, child sexual abuse is stored on iCloud, Apple allows it. And this was super surprising for me because think about, walking in Yalınjak or Amazon forest all alone. Think something bad about Apple and whisper it. Like, just say that actually iPhones are bad. All of a sudden, 10 Apple fanboys appear out of the jungle and tell you that you are wrong and Apple is fantastic, Steve Jobs is a god, etc. And people actually use this kind of posters on New York airport and nobody bothered. And this is wrong. Apple actually doesn't do this. The idea is as follows, by the way. When you upload the file to cloud, for instance, to your Dropbox or anything, for instance, just put a movie file to Dropbox. Dropbox does the following: calculate the cryptographic hash of it. If it matches with a copyrighted thing, then it simply erases, saying that this is copyrighted. Or if it contains anything like child sexual abuse, terrorism, they just erase it. So Apple does the same. But if you simply change 1 pixel of the image, then the cryptographic hash will be different, so you cannot detect it. So this law was to try to detect it by AI. But, Apple said that, and all of the academicians said that this is not possible. Passing that kind of laws will remove all of the privacy. So we were surprised by this, by the way. Generally we are against companies, but in this scenario, WhatsApp, Signal, Apple are together with the academicians. They are against these kind of laws. Then we were surprised that who are we fighting against? Of course, we are fighting against Secret Service of the countries, but people who put these posters everywhere, they have to spend a lot of money. And it turned out that they were funded by AI companies because they want these laws to pass so that their products can be used. So they said this kind of stuff to Apple. By the way, Apple doing its best to prevent anything like illegal files to be stored on the cloud. But then this happened. There are freely available data sets where you can train, and there was a data set, Lion 5B, which was used by many AI products. And a few people at Stanford said that let's calculate cryptographic hash of all of these images because there are millions of images. You cannot just check by one. So if you calculate them and compare it with illegal files, you can detect if it is, illegal. And actually, this is a homework I give for my students, so anybody can do it in 5 minutes. So students does it, obtain all of the hashes, and from a Microsoft database, they control, and they notice that actually it is here. Maybe we can move the mouse above here, but it says that they found more than 1,000 child pornography images in the data set. And many big companies use this data set in their AI algorithms, like Stable Vision, etc. So it turns out that AI people aren't that good at this stuff. Anyway, let's move on to fun stuff. So I really love data poisoning. I mean, I'm against misinformation. I give many talks about this, so it is bad. But when you do it against AI companies, it is super fun. So you just provide false information, but you put it in a way that real people cannot see, but AI algorithms, the bots that surf your web pages, detects this data, and without your authorization, they use it. So for a very long time, ChatGPT think that I'm a professor at computer engineering department at Koç University, and all of these three are wrong. But of course, there are correct data on the internet, so they solve this problem. But anyway, they are using our data without asking us. If ChatGPT can answer a question correctly, this is because you give a lot of data to the internet for the last 15 years, and nobody paid you any money. All of your Instagram photos, etc., they are used for AI training. So you can poison this data. For instance, the left images and the right images look identical to human eye. So for us, our perception actually understands what is in the picture. But actually, there's a difference, and this difference is shown in pixels like here. So we do some modifications to pixels, and this is the differences between these two. So AI algorithms correctly identify the pictures here, but on the right side, AI algorithm thinks that all of them are ostriches. This is how you can trick, because they don't understand like human, they look at the pixels, so you can poison the data, and this way reduce the accuracy of all of the AI algorithms, and it is super fun to do. I recommend you to do it. But of course, you should do it without damaging anybody. There are, for instance, many recipes, food recipes on the internet where ChatGPT collects. So people got angry because they were earning money from this. So they designed fake recipes, and when you ask ChatGPT, actually gives all of them as if they are correct. So you can actually poison yourself if you do this, follow these recipes and make a food out of it. Anyway, for instance, there is a stop sign here. Any human can easily understand that, and all of the AI algorithms actually detect that as a stop sign. But as you can see, there is a sticker here, which is specially put there for a very special purpose. So this AI algorithm with a 95% accuracy thinks that this is a speed limit of 70 kilometers. So instead of stopping, it just passes through and, kill the people walking around. So this is why we don't have autonomous cars right now. Actually, we were promised to have them by 2024, for instance, and we will feel like Batman, For instance, assume that my car is in Istanbul. I will tell to my watch to come here, and it will travel it by itself to this building. But this is why we cannot have it. The false positives will actually destroy everything. Also, even if we achieve this at some point, it will be almost impossible to autonomously drive in Istanbul streets. But anyway, in other cities, maybe it can be done. Okay, I'm speeding up, so a lot of people ask if their phone listens to them, because they say that I'm talking to a friend about a topic that we have never talked about in all our lives. We go home and we see advertisements about it. So the question is, does my phone listen to me? And the short answer is yes. Okay? So you can test this like this. For instance, assume that you don't see any car advertisements. I did the following. I took my phone very close to my mouth and said that I'm planning to buy a car. And I don't know which brand I should choose, but I should definitely buy a car. 10 minutes later, these are the Instagram advertisements you see. So whenever you install an app on your phone and give a microphone access, just think what you're doing, okay? Of course, if you're using after probably Android 12 or 13, you have a button which actually disables the microphone for all of the apps. So you should disable it all the time, and whenever somebody calls you, your phone will ask you to turn it on, or if you try to record a video, which actually works, by the way. And none of these actually paid us any money, so I'm moving on. So another thing people ask, what is the security of the free messaging apps I'm using? A lot of people, for some reason, think that Telegram is secure. Actually, Telegram is the worst in this list. But anyway, let's start with Facebook Messenger. They recently added end-to-end encryption because actually, in the past, what they did was they stored all of your chat on their server. So it wasn't an actual end-to-end encryption. By end-to-end encryption, we mean that the data is encrypted on your device to the person you are sending it to. So the server in the between doesn't see what you're sending. So in the past, Facebook saw everything and stored it. But in the United States, in a court case, there was a court case where they thought that a girl did abortion, and in that state it was illegal. So they asked Facebook to give the data, and Facebook has to give it in this kind of cases. And they realized that the girl talks to her mother saying that she really had an abortion, so the girl is in jail right now. So this is why they had to provide end-to-end encryption. In Telegram, in the past, there was no end-to-end encryption, and the default setting is it is turned off. So generally, whenever you use Telegram, your messages are not encrypted. So a copy of it is in the server, and that server's data leaked all the time. So all of your past Telegram communication, you can buy it on the dark web if you have the money. Currently, it has an end-to-end encryption, but you cannot turn it on if you are in a group chat. So if you're in a group, everything you say actually leaks. In WhatsApp, yes, there's an end-to-end encryption, but AI/ML algorithms perform client-side scanning. This means that on your phone, the algorithm runs and tries to detect. Sorry. So if you say, for instance, you are planning to buy a car to your friend via WhatsApp message, that message does not leave your device, but it is actually by an AI algorithm scanned so that you will see advertisements again, so that data is sold. So the correct solution is Signal, which is end-to-end encryption, and collect minimum data because this is non-profit organization. But of course, in order to give such a free service, you have to spend at least $50 million per year. So they do it by, since they are non-profit, they don't sell the data. So they do it by donations. So if you stop doing donations, you won't have Signal. Okay, so what you can do, you can insist on lawmakers to enforce AI explainability, fairness, and use of non-biased data. Be careful about your actions and what you share. Your actions not only affect you, but they affect your friends. When in doubt, you can use cryptographic protocols for anonymity. You can try to reverse engineer AIs and increase your score. For instance, at LinkedIn, remove all of your friends who are open to work and add all of your, head of your departments, etc., and see what kind of change it makes in your LinkedIn life. Just saying. Poison your data whenever you can do, and give your kids a unique name, especially if you have a common last name. So I've been a calculus coordinator for a long time, so I have seen many different names and make fun of, but then now I realize the wisdom in that. Because if you have a common name, AI might, mistake you for somebody else, and you might be accused of a crime or anything. But if you give them a unique name, like, Khan, Berke, Baby Sue, just go for it. So I will try to move fast. So there are many misconceptions about blockchain. So blockchain technology was invented by Bitcoin, so it is a digital ledger that stores transactions in blocks. But the transactions are stored in blocks, and their integrity is provided by cryptographic hash functions, and they are connected with this hash function. Each transaction is signed by a digital signature algorithm. So I will come to that when I talk about post-quantum security. So this is a distributed network. People are storing, so everybody is keeping the ledger, actually. Yes, this allows the information to be decentralized and unable to be corrupted by a single user. But misconceptions are as follows. Cryptocurrencies do not use encryption. So this is the biggest misconception. Everybody says that the Bitcoin is secure because everything you do is encrypted and written on the blockchain. There is no encryption there. Digital signatures or hash functions are not encryption. Not every blockchain requires high electricity consumption. Not every blockchain is permissionless. Cryptocurrencies, crypto assets are not sent or received. Only the ownership info is updated in the blockchain. This is super important because cryptocurrencies, crypto assets are not stored in the digital wallets. They're on the blockchain. This took a lot of our time to explain this to forensics people. So in a crime scene, for instance, a guy says that, yes, in my laptop, I have a Bitcoin account, for instance, it has 5 Bitcoins. So they think that if they don't connect that laptop to internet, nobody can withdraw that money. Actually, the money is not on that device. It's not in the wallet. It is on the blockchain. If you know the secret key, you can sign a digital signature and send the money to somebody else. Same applies for NFTs, by the way. Yes, since its introduction, 16 years passed, but we couldn't see much useful cases. We have cryptocurrencies, financial applications, NFT, which I like it, but people use it in wrong ways. Many academic papers that propose blockchain solutions are wrong or redundant, almost 99%, by the way. There are many proposals, but almost zero deployment. So in all of these papers, when they say that there is a blockchain solution for this, I look at it and I say that, okay, this is almost impossible. You have to store like petabytes of data. How do you do it? They say that this was just an idea. We didn't implement it. So a blockchain might be useful if a shared and consistent data store is needed, data is contributed more than one entity or auditing is required. Records are never updated or deleted after they are written. Sensitive data will not be stored as plain text. Control of the data store cannot be assigned to a single entity. Tamper-proof log of all data store rights is wanted. So in a solution you provide, if the answer is yes to all of these questions, then a blockchain might be useful. So if you have done, for instance, a master thesis or a paper essay that, but some of this stuff weren't necessary for us, yes, then your work was redundant. But this doesn't mean that blockchain technology is bad or something. Actually, there's a good new directions. Especially, I'm very happy with the secure multi-party computations combined with zero-knowledge proofs and open source codes about this stuff. Looks promising. So maybe in the future we will see examples. I'm saying this because in AI, we have many examples. Everybody is using AI applications. People are addicted to ChatGPT, but nobody actually downloads the blockchain and become a node, right? Maybe in the future. Okay, I'm moving on. Probably I'm running out of time. Yes. So let me talk a little bit about NFT images. So, also there's a misconception about NFTs. People think that if I buy an NFT, it is in the blockchain, it cannot be lost, and nobody can steal it. But the thing is that your image, video, or document is not stored on the blockchain. Actually, blockchain is not that large. I mean, you cannot put 4 or 10 megabytes of images all the time when you create an NFT. So they're actually stored on the internet. So what is stored on the blockchain? On the blockchain, actually, you only store a link that maps to the image. So Moxie made a very fantastic example for this. So he created an NFT. And when you look at the NFT at the OpenSea marketplace, it looks like this. But if you go to a different web page, a different marketplace, the image looks like this. So the question is, if I buy it, how will I see it in my MetaMask wallet? So if you buy it, it looks like this. So this is why you shouldn't be actually storing this NFT at a regular web page. And funny thing happened, so OpenSea got angry about this, so they removed this NFT from their web page. But then something strange happened. This NFT also disappeared from MetaMask. So this is strange. For instance, think about blocking TikTok in the United States, and all of a sudden you cannot visit TikTok in Turkey. This is the same thing. But the thing is that the data is in blockchain. So this was a decentralized solution, right? So why this happens? It turns out that MetaMask uses the library or APIs from the OpenSea. So this actually turns everything into a decentralized system, right? So here's another example. So I couldn't draw. Nobody taught me in elementary or middle school, because in art lectures, the teacher comes and says that this is the topic, just draw something. So any 6-year-old child draws a lot better than me. Then I read a book about drawing on the right side of your brain, and this is the first thing I draw. Then I realized that actually everybody can draw what they see. So I turned it into an NFT and uploaded it. And it turned out this is the link that is stored on the blockchain. So it is just a JSON file. So and this is IPFS. This is something like torrent. People voluntarily share that data. So if people stop sharing that data, actually your NFT gets lost. So in the JSON file, you have the name, the description, but also the link of the image. So this link actually the image that I showed you. But again, if people stop sharing it, then your NFT is lost. And as you can see, there are some /n's here. So whenever I press enter button, it turns into an HTML code. So it means that you can actually do some code injection here. And people realize this, and they actually very recently published a paper about this kind of injection in the URLs and HTML. So this way, you can de-anonymize people by sending them NFT airdrop. So if you use this kind of technology, people can see all of your browser history. So you should actually use a different browser to avoid this kind of attacks. Anyway, let me move on. There are many stuff that is wrong with NFTs. Researchers observed that more than 100,000 out of 3 million metadata URLs were changed. So you buy something, they change the URL, so the thing you buy actually change. So 4 out of 12 million NFTs at OpenSea actually are lost. People stop sharing it. So, and they are still cached there. If you buy it, they won't appear in your wallet. Anyway, I'm moving on. So entity is the non-transferable version of this, and in the past we gave it to the 2022 graduates by the help of Blockchain Society here. And let me briefly mention about metaverse. So the metaverse refers to digital worlds in which people will gather to work, play, and hang out, where you can own digital assets like NFTs and transact using cryptocurrencies. So think about storing everything on the blockchain, and you pay the money, you store it, and whenever you want to share, you provide your approval. For instance, think about all of your medical data. You go to a different country, and a doctor asks for it. You simply press a button, and doctor can see all of your medical data, or simply for your kids' education, etc. So this is the dream. Gartner said that 25% of people will spend at least 1 hour per day in metaverse by 2026. Is there anybody who spent at least 1 hour in metaverse here? Exactly. Thank you. So this 25% will never happen. Okay, this is a failed prediction. Also, they said that by 2026, 30% of the organizations in the world will have products and services ready for metaverse, but apparently people stop doing this. So let me briefly explain the misconceptions. Metaverse does not exist yet. There may be more than one metaverse in the future. This is also important because all of the TV reporters at some point come to me asking questions about metaverse just to show it in the evening news. I said that, why are you interested in this? Because I tried to explain the concept, the blockchain, Web3, NFTs, metaverse, and they are not interested in the technology. And then I realized that they're wondering things like, what if somebody buys the land of Hagia Sophia and put a message there which will be offensive to our country? I said that if such a thing happens, I will create another metaverse for you where it belongs to us. They said that, can you do it? Sure, why not? So metaverse will not replace internet. In some of the science fiction books, it was like this, but metaverse will use the internet infrastructure, and it is not about only virtual reality. You can also use, normal stuff. The main challenges is software development takes too much time, but maybe with AI solutions now this can be solved. Legal system is not ready for metaverse. Legal system is not ready for internet or AI. So think about what will happen in metaverse. Two people having an argument, one of them from United States, one of them from Turkey. Which laws apply? Which court we will take this to? So we actually dodged the bullet there. We are lucky that we don't have metaverse right now. Yes, some technologies emerge untimely and leave the scene. Most probably 10 or 15 years later, metaverse will come back, and maybe it will be successful at that time, but not today. Today is not that day. But think about 3D monitors or TVs. At some point, everybody showed Avatar movie and thought that I want to experience this at home. This is why we bought 3D monitors, TVs, and they're no longer produced, right? So let's move on to crypto part. So this is the main picture. Alice and Bob wants to communicate, but this communication channel, it doesn't matter if it is wired or wireless. Think about Wi-Fi, GSM, whatever the communication channel is. It is always insecure because we assume that there is a person that listens all of this communication. And this is what happens actually in real life. People record everything in the hope that if they communicate in an encrypted way, they hope that in the future they can decrypt it. All of the countries listen to each other in this way. So this is the picture. So in the land of cybersecurity, there is no such thing as friends, but there are enemies. There are only enemies that you haven't met yet. Okay? So this is the main picture. Assume that somebody is always listening to you. So if you use symmetric crypto, so if Alice and Bob agrees on a secret key beforehand and then use this communication channel, they can use encryption. But if you don't do that, for instance, Alice wants to buy something from a web page or do e-banking, think about these as computers, then you can use asymmetric key cryptography to solve this. So I will show an example. So as a mathematician, I have to do some mathematics at this point. So asymmetric crypto relies on some hard mathematical problems. So think about very large primes, P and Q. You multiply them, it is easy to multiply, and these numbers are really huge, like maybe 1,000 digits. But when you give somebody n, which is a super large number, and ask them to find these two factors, P and Q, it is computationally hard. And generally, this is used to explain this crypto concept, but generally we don't use it in practice, okay? This is RSA-related security, but it is easier to explain. The problem generally we use, all the internet security, by the way, relies on this sentence. So if you're interested, please focus on it. For a large prime and non-valued g and y, it is computationally hard to find x such that g to the x is y modulo p, okay? So let me show an example to picture it in your mind. So this is a small example. This is a small prime. I took the x power of 3, and modulo this prime, it is this. So question is find x, okay? Of course, in this example, you can try one by one, and it is easy to find. But think about when this p is large, maybe hundreds or thousands of digits. So you might think that I still don't think that this question is hard. I can solve it. If you're thinking like that, go home and do it. This means that you can withdraw every money in the whole world, listen to White House, and listen every encrypted communication on the internet. So this is a hard question, just trust me, okay? So this is how it works. So whenever you visit a web page, what you do is you randomly choose a number A, so calculate g to the a modulo p, calculate this capital A, and send it to the person. For instance, this is Amazon.com, and you're trying to buy something. So the person, the enemy, listens and captures capital A, but from capital A, they cannot capture small a, because I told you that this is the discrete logarithm problem and hard. B does the same, choose a random number B and sends you this. So now that you obtain B, you calculate the 8th power of it, and the Bob calculates the bit power of A that you sent. So at the end, you calculate the same number. So you agree on a secret which nobody knows. And from this point on, you can use it as a secret key and do encrypted communication. This is what you do when you do e-banking or e-commerce, when you buy something, okay? But things are a little bit more complicated. We don't use this problem, but we use a little bit complicated version. So let me do a little bit algebraic geometry. It will pay off. So this is an elliptic curve. Depending on the choice of A and B, the picture becomes this kind of funny. But we have a very strange addition formula. For instance, if you want to add 2 points on this elliptic curve, P and Q, you draw the line, it intersects at the third point, take the reflection with respect to x-axis, and this is P plus Q. Very weird way of defining an addition operation. But if you want to at the pointer itself, you draw the tangent line, it intersects at another point, you again take the reflection, this is 2p. So now you can do it and obtain 3p, or draw the tangent, obtain 4p. So there is an elliptic curve discrete logarithm problem. So you choose a very large number d, at this point to itself d many times, and obtain a point q on the elliptic curve. D is your private key, Q is your public key. So whenever you send Bitcoin or elliptic curves to somebody, actually you are sending money to the point Q on the elliptic curve. Strange, right? So you claim it by knowing D. Okay? So this is even harder than the previous one. All of the cryptocurrencies, almost all of the e-banking, everybody is using this. Okay? So this is also, if you want to digitally sign something, you sign it with your secret number D, and everybody can check by using your public key Q. Okay. So the problem arises with the quantum computers. Okay, so you see news saying that quantum computers solve the problem which will take millions of years on a classical computer. So people think that quantum computers are super fast computers, but this is not the case. Actually, they are very different. They rely on quantum physics, and actually, not every algorithm can be run there. You won't be able to watch a YouTube video using a quantum computer. Okay, so it is not something like that. But they can do some parallel operations, but this can be used to solve only some of the problems. So this also, people then wonder how we can use quantum computers on artificial intelligence, because nowadays we use huge number of GPUs to solve all of these, training, etc. And people think that if we have quantum computers, then AI will be fantastic, right? But the thing is, actually, the effect will be none. Because all of these AI algorithms we have seen, there isn't any analog on the quantum computer so far. So actually, if you invested in a Kickstart company which claims that they will use quantum computers on machine learning, maybe you should check what they're doing, and maybe you can take your money back if you have the time. Okay, but the problem is that development of a large quantum computer would allow to solve all of the hard problems I mentioned: integer factorization problem, discrete logarithm problem, elliptic curve discrete logarithm problem. So it can be solved in an instant, in polynomial time. So if somebody builds a very large quantum computer, they can steal every Bitcoin, every Ethereum, but every money on your bank. Okay, so it is important. So this is why we take it seriously. So the question is, how big quantum computer are we talking about, right? So IBM has something like 127 qubits. Google then announced that we build a quantum computer with 140 qubits. But all of the algorithms I show you, you need around 2,000 or 3,000 qubits to be broken. So you might say that, okay, from 100 to 5,000, it is not that hard. But the thing is that there's a very huge noise in this quantum computer. So in order to have this kind of logical qubits, you need to build a quantum computer that has 7 or 8 million qubits, physical qubits. So it looks like we won't be having such a quantum computer in maybe 50 years or 100 years. Maybe it won't be ever built. So, but the problem arises like this. What if somebody builds such a quantum computer 20 years later? I mean, maybe in 2050 somebody will do it. So everything they recorded today, they will be able to decrypt when they build such a computer. So government secrets, etc., has to be quantum secure for this reason. For our personal use, we don't care. 100 years later, we will be dead anyway, so we don't care if they listen to our communication at the time. But another problem is that this is a very new technology. So instead of maybe building such a huge computer, maybe the technology will develop and people will reduce this noise. So maybe they will come up with a solution to build such a huge computer soon. This is why we should move on to post-quantum cryptography, where these algorithms are secure even against quantum computers. For key establishment algorithm, like the one I showed you, there's an alternative which NIST recently chosen. So actually Signal uses this. So even somebody builds a quantum computer, they won't be able to listen to your signal communication, and we have some algorithms. Okay. So I will finish very fast. So a lot of IoT devices and number of internet-connected IoT devices actually exceeded non-IoT devices in 2020. And in these devices, they don't build in a secure way because there isn't any regulations telling who is responsible for it. I mean, the person who builds the device, who sells it, or who puts the software. So none of them takes responsibility. So instead of building something secure, what we do is, actually we do monitor the network traffic and try to find an anomaly and detect a problem. So we use AI to detect anomalies, and the attackers use AI to evade this AI detection. So depending on their algorithm, we improve our AI. So they look at our AI and they improve their AI. So this goes into an AI wars which is not as fun as Star Wars, of course. But so this is the future of the security. We will be seeing many AI wars in the future. So let me show you some examples of real-world security. So even if you don't have quantum computers, we have this kind of security problems. For instance, you buy a recent hardware, software, and you think that you are secure, then you use smart cards, right? So, for instance, if your smart cards, maybe in your wallets, you have smart cards, and if it is MyFair Classic 1K, I can clone it while passing next to you. So many governmental smart cards we can copy. Actually, we can clone them, and we can enter any place almost where we want. So I cannot give names because they don't change their IDs. But if you're interested to know, after the talk, I can check all of your smart cards to see if I can clone it in a second or not. So another news, for instance, I really love this because you can actually steal any Tesla if the owner of the Tesla has the keys on them and you stay next to them for like 5 or 10 minutes, communicate with their key fob using Bluetooth. You can go home and clone it and steal their cars. So as a solution, the company who made these key fobs said that let's do double encryption, thinking that they will prevent the solution. But now instead of 5 minutes, it takes 10 minutes to clone it. And this is because they use bad crypto. But if you use a good crypto, we can sometimes still break it. This is a nice example. So they use AES 256. This is the key size. So it is military-grade security used in PlayStation Vita. But now the thing is, even though the algorithm mathematically secure, your implementation may not be, because I have physical access to the device. I can measure the power consumption. I can measure how much noise it makes. Or even more, I can increase the voltage and introduce faults and check how it behaves. So, of course, when you increase the voltage, sometimes they die. All of the martyrs who died during the process. But at some point, the attacker succeeded and captured the secret key. This allowed them to actually own any game that is designed for PlayStation Vita without paying any money. This is why they are no longer sold, because you can actually clone every game. So in order to solve this, NIST made a competition to choose a lightweight algorithm so that these can be used in very small devices that will be used in IoT. There were 56 algorithms in the competition. In some of the candidates, there were Turkish designers who are METRE graduates, but also the person who was responsible for this competition was our graduates, so METRE graduates are everywhere. So let me finish it with my research. I generally do cryptanalysis of symmetric encryption algorithms. So I try to find a weakness to show if the algorithm is good or bad. So in my master's thesis, I broke an algorithm that is called HEIDS, which is a standard in North Korea and also an ISO standard, but this prevented it to be a lightweight blocks cipher standard at ISO. In my PhD thesis, I also attacked Sony's algorithm, Clefia, which is used for digital rights management. I found the best attack, but it is not practical, so I cannot give you any free games. Sorry for that. But this shows that the algorithm is good. This is why they don't change the device. So all of these attacks were theoretical attacks. But sometimes so it gives some kind of a confidence. But if you do something practical, then things got a little bit ugly. So let me mention what about my recent work, which I presented last month. So we recently obtained practical attacks for GSM, GPRS, Tetra, and NSA design spec. So NSA designed an algorithm, for instance. It has some variance, so this number actually represents the secret key size in bits. So we can break this in a year if you use 9 GPUs. We can break this if you use 1,500. And we can break this if you use 22 billion GPUs, which is, of course, not practical. But maybe in 20 years, this will be practical. But this is also used in ISO for RFID air interface standard. So anything you buy today, maybe we can break it 20 or 30 years later. The second thing is Tetra. So Tetra is a European standard, but it is used all over the world by governments, military, police, secret service, almost everything. These radios they use Tetra. So there are two versions. One of them uses 56-bit security, so we can break it with just 29 GPUs. So if you have thousands of GPUs, you can break them in real time. For the most security it provides, we can break it with 1.3 million GPUs. So Microsoft will recently announced that they are going to build a data center which will have more than this many GPUs in a single center. So if people decide to do cryptanalysis instead of AI training, so they can break communications like this. And the final thing is that I will talk about GSM security. So in 2G, there was an algorithm called A51, and it was very easy to break in real life. So there were some build-up tables, you can use them, and in real time you can break it. So in 3G, they used a better algorithm, which uses a larger key. And with the introduction of 3G, this A51 is replaced with A53 in 2G communications. With this algorithm, but it uses 64-bit keys, which is short. So far people thought that nobody can break it, and they thought that 2G and GPRS are secure, but we showed that we can break it in 38 hours if we use this many GPUs. So if you have more GPUs, you can reduce it to minutes, and when you receive a two-factor authentication SMS message, somebody can actually break it and use it. So this is why actually GSM operators should disable 2G communication. And of course you might say that, okay, we are using like 4G now, and people only think that this increases speed, but it also increases security. But recently, when I was paying at a restaurant, I realized that the device is working on 2G. I asked them why this is the case, because the device was new. They said that the reception is not good there, so the person responsible for selling this device come and said that just use 2G because it is better. So sometimes professionals downgrade our devices. Generally, the attacker tries to do this. When you use 4G, they forces your device to think that there isn't any 4G reception. They force you to go downgrade you to 2G and attack it. Here, sometimes professionals do it. This also happens at home. When you buy a modem or router, in the settings there are protocols like WPA, WPA2, WPA3, and your internet doesn't work. You call to customer service, they say that choose WEP. And all of a sudden everything works, and you say that, okay, the problem's solved. But if you use WEP, we can break it in seconds. So your neighbors might be using your Wi-Fi. Okay? So thank you for your attention. If you have any questions, I will be happy to answer, but also we can talk afterwards at the cocktail. Thank you for listening to me.
Dolu dolu geçen bir Learn and Connect sunumunun daha sonuna geldik. Doçent Doktor Sayın Cihangir Tezcan'a dijital çağın karmaşasında pusulu olarak paylaştığı vizyoner değerlendirmeleri için teşekkürlerimizi sunuyoruz. Etkinliğimizin ikinci bölümü olan Connect kısmında siz değerli katılımcılarımızla birebir temas ve sohbet imkanı bulacağımız kokteyle hep birlikte geçiyoruz. Kokteylimiz hemen büyük fuaye alanında gerçekleştirilecektir. Katılımlarınızla değerlendik. Teşekkür ederiz. Güzel bağlantılara vesile olmasını diliyoruz. İyi akşamlar.
Teşekkürler.